Alright, welcome to example 11. In this tutorial we're going to talk about how to create lighting arcs as seen right here. So we're going to take a look at how to create these kind of with a really cool motion and a really cool look to them. We're going to create this using particles, believe it or not. But yeah, let's start. So we have a source here. I just done a sphere. I've shrunk it down so it has 0 in the radius of y. So I put it to 0. Just to get something like the source. Then basically what we're gonna do, we're gonna birth particles on the top of this. So it's gonna look like this. It's gonna have random points zipping around like this. And how we do that is by going in here to the popnet. So this is our first popnet, and this is the first time we're using particles in this. So we want to take the geometry, we want to do scatter onto surface since we have a primitive. We want to put constant convection on, and the birth rate is up to you, but I put it to 12 because it seemed to work pretty fine here. The less particles, the less arcs you want to have, so it's up to you really. But let's play along with 12 for now. Life expectancy is going to be 0.2. Life variance is going to be 0.1. And that's it. No velocities because we want it to stay in place. But yeah, it's going to look like this. Just randomly zipping by particles that have a really short life. But you can obviously bump that up if you want your arcs to live longer. But usually when you do lighting, you want it snappy, you want it fast, but still slow enough to see some kind of detail and change in there, sort of. Anyway, next up, you want to create the actual geometry these lightings are coming from. And a simple way of doing this when you have these particles is just to do transform. Transform, and you transform it up like that. So now you have the particles up here. They're doing the same thing up here, just transform them up. So it's kind of a cheap trick, and definitely if you have moving geometry you want the arcs to go from, this is not going to work. How you will have to do it in that case is either you can create absolutely your own points, or if you actually want to use the points coming out of the popnet, you can do it like this. This is a little bit of a tip. You can use a ray node, okay? So we're going to take these, we're going to pipe them into ray points and primitives. You can take your geometry that you want them to come from. You can isolate a little bit of them, or you can just take the whole geometry. Doesn't matter. But since we don't have any geometry, I'm going to take a sphere. I'm going to pipe this to the second input of this. And then I'm going to put this to the range node to minimum distance, which means that all nodes are now going to be pasted to the surface of this sphere. I can now transform the sphere around, and the points will follow it, which actually means that if I then instead merge these in, I'm going to go over this later, what happens here, but I'm just going to demonstrate that the lines actually will follow the sphere. So let's go to a cool moment like here. Now, if this sphere was animated, it will always follow along, you know? So if you have something that's animated, you definitely want to look into doing something like this, or actually creating your own points on the surface. That's going to work just as fine. I'm going to explain why, but yeah. Cool. So we don't want to do this for now. We're going to keep it simple, but it's an option if you ever want to like mess around with animated geometry and having lightnings coming from them. Anyway, we have transform. We transform the same points up. That means we're going to have the same point amount. We're going to have the same IDs, which is really, really important for this thing. So as we remember, the points, the particles that come out of popnet always have IDs to them. Even if they die super quick, they will have an ID. And this is useful because we want to be able to transform these points up. They have the same ID, just transformed up. We're going to merge them together, which means that now we're going to have matching IDs between these points. The point number is going to be different, but the IDs are going to be matching because we are taking the same particles and just duplicating them, basically. And that's going to be useful for us now because we are going to add lines in between these points, just like that. How we do that is with an add node, just add. We go to polygon tab, we go to group, and we go to add by attribute. And the attribute we want to add by is, you guessed it, ID. That means we're going to create primitives between points that have matching IDs. And that's cool, because now we have the actual lines that we want. Great. All right, cool. So now these lines are very low res. They only have 2 points each line. We want to resample that. So we're gonna put on a resample node. Gonna create a lot of lines. I'm gonna put the length to 0.1. It's a default value. Is to get a lot of lines, a lot of points, which means we're gonna have 134 points per line now. Next up, we want to create an UV attribute along this line. We have kind of done this before, and we're going to use this UV attribute to kind of define where we want our noise to be on this line, depending on if it's an endpoint or if it's in the middle of it, or things like that. So that's simple enough. We just drop down a UV texture node, and we put the texture type to rows and columns, and they put the attribute class to point. This means that now we have an UV attribute running along this line. I'm going to show that by using a color. I can put it to ramp from, we can put to random, and then we're going to put to UV. Actually, let's put it ramp like that. We can see it go from red to green, which means we have a 0 to 1 value going along this node, this line, which is perfect. That's all we want, because later on we can use it in a ramp, we can fit it, we can use it in a ramp, and it's going to make our lives super easy when we want to define where the noise is going to be. Anyway, we're up to that now, actually. So lighting is very noisy. It's kind of a very different noise from many other things we want to create in Houdini. And the noise is kind of like this. Usually you want to think of a lighting as something that is beamed at a point. It's just light, like electrons connecting between two differently charged areas, right? So you kind of want to think of it as something that is beamed and then kind of dispersed, which means that a really nice effect to do with lighting arcs is to have them first be very straight, not so much noise to them, and then kind of over time kind of dissolve into a more noisy pattern. If you look at this first line here, you can see if I just scrub through a couple of frames, you can see that it's super straight right now. 1 frame, 2 frame, 3 frame. It's kind of gone after 3 frames, but you can still see that it kind of starts arcing as the time goes along, which is a really cool effect, and it kind of brings more power to your lightings. Because having just this type of shape all the time, just wiggling about, it's kind of boring and not so aesthetically pleasing to me. So how are we going to do that? Well, as we remember, we have an attribute here from these called ID, and we have an attribute from these called age. We are actually going to use the age to do this kind of effect, and that's why I really wanted to use particles to do this, because we get the age attribute for free. Otherwise we have to kind of calculate it otherwise, but yeah. So let's dive into the lighting VOP here. In here we're going to do all our noises, so it's going to be a lot of things in here, but I'm going to take it step by step and hopefully can clear it up. Just remember, we're going to work a lot with these ramps, kind of defining things, and with the age and with the UV. So let's dive in. So in here we have a lot of nodes. First of all, disregard this part for now. I'm going to go over that in a minute, but let's think about this. So obviously you want to do a noise on this line, okay? So what better node is the turbulent noise, okay? So we want to drop down one of those. We're going to connect the global position from here, P, to the position here, okay? Then we kind of want to start defining some other things. Since we are going to have multiple lines, we want them to look and act kind of differently and randomly, which means that the frequency of our noise can't be the same, and the offset can't be the same, and the amplitude can't be the same. Therefore, we have to go in and actually do some kind of randomization. And we have a lot of nodes to do that. We have our random node, for example. So let's start off by focusing on the frequency. The frequency is the frequency of the noise. So the higher the frequency value is, the more frequent the noise is gonna be, basically. We want to define this randomly per line, which means that we kind of want to grab the primnum and do a random value from that. So the primnum, as we remember, is the number of a primitive. We can have points and we can have point nums. They are not going to be very valuable in here. Instead, we want to use the primnums. The primnums you can display by clicking this button here. So if you click it, we can see that we have now a number per line or per primitive. The primnum for these are 0, 1, 2. If you then pipe that to a random, we're going to get a random value for each of these. For each of these lines, we're going to get a random value between 0 and 1. That's great, because now we can use a fit node for that goes between 0 and 1. We can fit that to any values we want. I mean, I fitted them to kind of high values here. So I fit into minus 34 and 35. Which means that randomly these lines will get a frequency between these two. Okay. I've kind of piped into a float to vector. I piped all three values into the float to vector. And I piped the vector into the frequency of the terminal noise. A vector frequency is a vector, so I kind of did this to be clean, but yeah. So the frequency can now be between minus 34 and 35, depending on the primnum of each of these lines, which means that we now have a random frequency, which is great. This is exactly what we wanted, so that's done. Perfect. So remember, this is the frequency. Random to a fit, to a float to vector, and into frequency. And we take the random from the primnum. Cool. Next up, we want to kind of define an offset randomly for each of these lines. The offset is basically where we are looking at our noise pattern. So if the offset would have been the same for each of these lines, the noise would look very much the same. Even if the frequency is different, the offset would still be very similar, which is something we don't want. So we want to do the same kind of process here as well. The offset is a vector as well, so we're gonna keep that in mind. We're gonna take the random. We're gonna take a random from the ID. Okay. Actually, I made something wrong here. We do not want to take the random from ID. We want to take the random from the primnum, exactly the same as before. We're gonna fit that between the values here. We can even fit them between higher values, like that. Maybe not. Let's keep them. Let's keep them as they were. Let's keep that as they were, 0.6 and 6. Anyway, we're gonna put a random to that, so we get a random value between 0 and 1. We're gonna pipe that to a fit, so that we get these kind of values between minus 0.6 and 0.6. We're going to do the same. We're going to pipe it to a vector to float, or float to vector, sorry. We're going to pipe the vector into the offset. So now we have different offsets for each of these lines, which is going to give us cool results, I think. Anyway, next up, we have to kind of be mindful of the amplitude as well. Let's just do this. Anyway, we have to be mindful of the amplitude. So the amplitude, we don't want the amplitude, as we remember, we don't want any amplitude in the endpoints. Okay, and this is where our UV attribute is going to come in handy. Our UV attribute is going to be able to, as of for now, it goes from 0 to 1. We want to pipe it into a fit, and we want to do a ramp on that. Or actually, we just want to do ramp on that because we have a 0 to 1. Sorry, we're gonna do ramp on that goes from 0 to 1 back to 0, which is gonna look like this. So remember ramp 1, okay? That ramp is gonna look like this, okay? We have from black, white, 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 black. I've kind of defined the ends a little bit more to make them even more narrowly, like to make only, maybe even only the last 5 points not have any amplitude. But this is the kind of ramp we want. We want black to white to black, which means 0 to 1 to 0. And that means our amplitude can never be more than 0 at the endpoints, but it can be 1 in the middle. We're gonna pipe it to multiply. We want to multiply by some things. So let's take a look at that. So next up, we also want to multiply the amplitude by the age, and that is why we get these kind of behaviors, where over age, the amplitude starts getting higher. Okay, here the amplitude is almost 0, right? For all of it. While we go a little bit forward, here I can tell it's like maybe 0.2 here. And that's because we have taken the age, the global age from the particles. We have piped that to the fit here. And we kind of know that the age of our particles can never go over 3. I put it to 0.4. Doesn't really matter because we're not going to use these values as a definitive value. We only will multiply by them, so it's fine. We sorry, I lost my train of thought. Yeah, so we want to put these like this. So the fit node is going to go from 0 to 0.4, which means that at 0, age 0, the line is going to have 0 amplitude. We're going to multiply by this. So this whole thing is multiplied by 0. Okay? When the age reaches its maximum, which is 0.3, but put 0.4, we're going to put 0.3, whatever. 0.3, which means reach the maximum age, we're going to multiply everything here by 1. And that's how we can achieve these kind of growing amplitudes in our lines, which is cool. And then we're going to multiply everything by 4. This is kind of a general like multiplier. So if you want more amplitudes, you can just like dial this up and it's going to give you that. But yeah, I think a 4 is a pretty good value. I kind of like the amplitudes we get with just doing like this. But yeah. Anyway, that's actually it for the noise. Now we're just gonna pipe that into the amplitude up here. We're gonna add an add node after the turbulent noise. We're gonna add this onto original position. So we're gonna pipe position into the first input of the add, and the second input the turbulent noise goes. And then that goes to the position again. So we output the position. And that's how we get the noise. Which is cool. This is how it's gonna look. Great. Anyway, next up, we also have another attribute we're going to generate here called the width. The width is an attribute we're going to use later because we want to kind of define how wide these lighting arcs are going to be when we render them. And a general note for that is that we actually want to do the same there. We want them to be kind of narrow at the ends or the tips of the lines, but in the middle we want them to be thicker and visible. So generally you kind of want to set up this, cannot set it up by itself. But what I've done here is I'm basically just taken all the values we grabbed for our amplitude and I put them into a multiply. I've multiplied that by a random from the ID. Just to give them some random width, some random, because this is going to multiply by 0 to 1. We actually don't want it to be 0, okay? So we're going to put a fit afterwards. We're going to put that to 0.1. We want to clamp it so it can't really be less than 0.1. So that's going to multiply as well. So the amplitude multiplied by these random values per line, okay? And that goes out to the width. And yeah, that's it. So width is now in effect. We can now use it later on when we want to render these or we want to wrap them in polygons. I'll explain it later on, but yeah, we now have a width attribute. Cool. So it's a lot of things going on here, but yeah, take a look at this and play around with it if you get the chance. But yeah, that's it for this lighting bop. We now have our noise, which is great. Look at that. That's cool. Anyway, now these main lighting arcs are actually finished. What we want to do now is we want to create some secondary lighting arcs. How we want to do that? We want to define an area where we're going to birth new particles that will then later on connect to the ground. So we want to say that this area down here can generate lighting arcs, additional smaller lighting arcs. We want to birth particles on this area only. That kind of this will connect with the ground later on. So one way of doing that, we're gonna delete the top part of this line by doing this. We delete and we do a bounding volume, and we do enable and we do bounding box, and it kind of define what part of this lines we want to delete. Another way to do this in a more efficient and more procedural way is to actually define with a point wrangle. Okay, you can do this in a VOP as well, but I prefer deleting things with a point wrangle. So let's say we want to delete the top part. How can we do that? We can do it with a position, but what if we type like this, if at px is greater than 5, remove point at yourself, yourself, comma, at ptnum. Okay, if we have that, we are gonna delete everything that is greater than 5. All right, but that is a kind of destructive way of doing it, because now we are deleting it. That's fine. We're deleting points and we can define a more smaller area. But if we do as before, we do array a sphere and if I'm telling you, if our source or our source object is animated, this is not going to work so well, since I'll show you. Hold on. So if this is animated, you see that it's only grabbing the position Y. Therefore, we kind of want to use the UV attribute instead. So how we can do that is, instead of writing PY, we can just type instead UVX. If that's greater than, let's say, 0.5, then that happens. And this is because the UV attribute is going from 0 to 1. Okay, so if you put 0 to 0.5 here, that means we're going to delete half of this line. If you want to delete 75%, we can put 0.25. So that's a way better way to do it. And now if the things are animated, it will still work very much fine. But this is kind of old course. I'm going to leave this here, but I'm going to start deleting it with the delete sub anyway. So now we're going to do kind of the same kind of general thing as we did up here, but in a smaller scale. We want to birth particles on these lines. Simple as that. So there's going to be these lines are going to be the same way. We're going to do in the source here, we're going to put it to scatter onto surface. We're going to birth, we're going to put them to not 12 this time, we want less smaller arcs, we're going to put it to 6. Have the same age. Let that let it simulate, and it's going to look like this, just random particles bouncing around on the lines, to make sure that the points are actually sticking to the lines. We're going to ray them on to the closest line they can find, and that's going to look like this. Great. Next up, we want to kind of define the ground. If you have a impact object, you obviously want to pipe that into here, but that means we're going to ray these points onto the ground, so they zip around like that, which is great, exactly as we did up here. As we remember, they now have the same IDs since they went out of the particle system, and they are the same particles. They are like split up here, or they are like kind of duplicated in a sense. We're gonna do some point jitter to the ground particles. We're gonna transform them a little bit to the side, just for fun. And then we're gonna merge them together again, just like that. And now we have exactly the same amount of particles, the same ID, and the same age. So that's great. Now we're gonna do the same thing as we did to the main arcs. We are simply gonna do that. We're gonna copy and paste this to here, and it's working great. So now we have secondary arcs here, zipping around. And that's cool. If we merge the main arcs from here with our secondary arcs to here, it's gonna look something like this, which is cool. Look at that. That's cool. It's like a secondary little arc going there. Yeah, you can get a lot of really interesting shapes to this. This is cool as well. This one has 2 secondary arcs. Looks really good. I like it. Yeah, and then as I said, we now have a width attribute that is the same as the amplitude. And that's cool because now we can mesh them. Mesh these lines by in the poly wire. We can mesh them by wire radius. We can put that to $width, which means we will use the width attribute. I have also multiplied that down a little bit to make them thinner, but yeah. So this is how they look. They have a lot of difference to them and like a lot of different characteristics and different width and different speeds and yeah, everything. So yeah, that's pretty much how I've done this. I urge you guys to take a look at this and go through this. It's a lot of things, but I think I hit the major points here. Anyway, I hope you enjoyed this tutorial. This is how you create arcs and lighting stuff. Cool. See you guys in the next tutorial. Bye.